reminded of the stories they tell about C.S. Lewis when he would teach. He would have lectures that were designed to be exactly an hour, but people were always stopping him in the hallway. So he would start his lecture on time, even if he wasn't in the classroom yet.
Seriously.
So
Wow.
that he would end on time. Well, I think we've started, and so we're recording. Why don't we begin, as we usually do, with a roundup of where you are and what the weather's like. So, Chris Kennedy, give us a start.
Yes, it's New York. The weather continues to be dreary, and then it will be sunny and humid again, and then it will be dreary again. We've had 15 Saturdays in a row with rain, but that's just how it goes sometimes.
Okay. We are in Castel Gandolfo, where it's in the low 80s during the day and a little humid, but not so bad that we've had to turn the air conditioning on in the classroom yet. Though I think it's only a matter of days. The difficulty is the air conditioning's kind of loud.
Okay.
So that's why we've been putting it off. Bob, where are you?
I am in Clinton Township, Michigan, northern burb of Detroit. It is 70 degrees out right now, and it was a beautiful walk this morning. So, yay! And I am back from Austin, Texas, and it was like 100-degree heat down there while we were down there. Yikes!
All right, Jim.
Good morning, Jim here from Anthem, Arizona, just north of Phoenix. It'll be 108 in downtown Phoenix. Where I'm at, it'll be about 104. So the summer has already arrived here in Arizona.
Right. Justin.
I'm in Watertown, Connecticut, about 90 miles from Manhattan, where Chris is, and it's 65 degrees, raining yet again, and hopefully it'll clear up tonight for the strawberry moon.
Okay. Joel.
Well, I'm 35 miles south of Tucson. It's already 87, due to get to 105 and scheduled for 110 this weekend.
Vatican Observatory.
Okay. Jeff.
I thought you were just putting on live. You need help? I didn't realize it was so much.
Okay. Somebody should be muting themselves.
Yes.
Jeff, go ahead.
This is Jeff Madley. I'm out in Manorville, about 70 miles east of New York. And the weather here is terrible. It's about 62, 63 degrees, and it's raining, but it beats the heat. So it's not that bad. And, that's about it. Haven't seen too much in the sky lately. So,
Gary.
Milwaukee, Wisconsin here, and it's like some others up north. It's been raining on and off for a couple days, and in the 60s.
Richard Sam.
Corpus Christi, Texas. Can you hear me?
Yep.
It's about 84 degrees here, a little bit overcast. We're looking for some rain. It's been dry here for months.
Oh.
People from New York will send you some.
it's true.
Larry.
Larry Lebowski. I'm north of downtown Tucson. It's mid 80s right now, getting up to like Green Valley, 104, 105 today. And we did have a third of an inch of rain a week and a half ago, just before I left for Mount Graham.
Did you? Okay.
Again tomorrow.
Okay. Carmen.
Hi, just to let Almudena know, I am from Uruguay, South America. But I am currently in Washington, D.C., visiting my son. And it's 27 centigrades, but cloudy.
Okay. Francis?
Hi, Davenport, Iowa. 70 degrees and sunny, cloudless skies.
Perfect.
Yes. Linda.
Hi, Linda and my husband, Paul. We're from Allentown, Pennsylvania. It's cloudy, rainy, not really warm enough.
All right. James.
I am from Southington, Connecticut, not too far from Watertown, where Justin is. And just like Watertown, it's raining, it's 66, and just a little taste of summer, but mostly cloud.
Okay. Juan Pablo.
Hi, Juan Pablo here from Phoenix, Arizona. It's a beautiful, clear day, and it was a beautiful, clear night. My phone says it's 33. It's metric.
Right.
It's gonna get up to 40 degrees Celsius today in Phoenix.
Right. When I was learning Italian, and that was in the middle of June, everyone had to say something about their home country, and so in Italian. And so I had seen the newspaper and I said, Ieri nella mia paese il tempo era 52 gradi. And everyone laughed because they said 52. That can't be right. You've got the numbers wrong. But it was, in fact, 52 Celsius, 123, I think.
Oh, really? Wow.
So it could be worse, and it probably will be before the end of the summer. Deacon Joe.
I'm just a few miles from Father Juan Pablo, so it's the same thing, but in Fahrenheit, it's going to be in the hundreds.
Right. So Maureen?
Well, I'm here in New York, where you probably already heard from Chris or somebody. It's pouring rain. And we had a little bit of smoke from the Canadian fire, so I'm not able to report very much. Someday I'll surprise you, though.
Right. Briso.
Oh, hold on. There it is. Hi. I'm in Batavia, Illinois. It is bright overcast and 69 degrees or 21 C.
All right. And I have something called David's apostrophe S. I don't know who that is.
David Moran.
Oh, okay.
83 in Raleigh. So humid, expecting rain anytime.
Okay, great. Well, this is the time when Paul Gabor usually gives us an update on the telescope. He's not with us, but Larry, as you say, you've been up there recently. So what can you tell us about the
I haven't
telescope?
been up to Mount Graham since Friday, and I don't go back up again until tomorrow. So literally 4 days off, whatever it is. But it should be fairly clear for the next couple of days, which is better than our last run, where the equipment generally worked okay. The weather did not, like 95% humidity for 2 days in a row.
But
So-
without the rain that everyone could use.
No, without the rain, but yes, it was very humid, very cloudy, but then it cleared. So we did get at least like a day and a half's worth of observations in.
Tell us about the observations you're doing.
So doing asteroid follow-up observations, which is somebody's discovered an asteroid and there might be one or two sets of observations. How do we extend the orbits? And that's primarily what we do, but we also do recovery. So we recovered an asteroid that had been observed last year for the first time and had been observed in 2/3 or almost a year, and observed it again. So again, extending its orbit and improving its orbit.
I also know that Jean-Baptiste has been doing similar work, plus taking asteroid colors and spin rates in his time up there. Who else has been on the telescope? Do you know?
I think I'm not sure anybody else has been up recently because they had the issues with the rotator for a long time.
Right.
So it's been
That seems to be working
sparse.
now?
Everything seems to be working now.
Okay.
The computer system every once in a while decides it's going to do something silly, but we're getting around those things.
I can't believe that computer systems don't work perfectly the first time out, because after all,
When you're
they're
observing
entirely-
when you're observing and all of a sudden it says the mirror no longer has support because the little pillows that are air support pillows underneath have supposedly failed, at which point you go, okay, is the mirror going to break in half or do something silly like that? But it turned out to be a
Which is
mistake,
why,
an error. Yeah, it was
which
a
is
sensor
why,
error.
even though, yeah, the system, the automated system was installed many months ago, but we're giving it a good year of rundown to have a human being next to it to check up a few of these things. nonetheless, from what I hear,
I would call it an okay year. There are some ups and downs.
Yeah. Well, okay year. I'll take that.
It's getting there. So
Mhm.
all we need is a new camera now.
So if people are interested in the meaning behind the work that Larry and Jean-Baptiste are doing, NASA has put out a new documentary film, something called, Planetary Defenders. Is that the title I'm thinking of? You Google
Something like that,
NASA
yes.
Planetary Defenders movie on YouTube. You unfortunately won't see any of our guys, but you will see other people who work with us, who are friends of ours, who are doing the things that we do, including that about 2/3 of the way through, I suddenly heard a very familiar voice. And then he came on camera, which was Andy Rifkin. And Andy, of course, was a student of Larry's many years ago. Well, it's a delight to have all of you here. And it's especially a delight to have Almudena. Tell us your full name, because I can never handle the whole Spanish last name.
Okay, so Almudena is the first name, and then in Spain we use two last names, father and mother. These days you can choose to have your mother's last name first. And yeah, with everybody at school, from when you enter daycare, you start using your two last names for everything, every official document. And also I decided to use my second last name when I was about to publish my first paper. It turns out that there is another astronomer in Spain who has its name initial as me, and Alonso, and I don't have a middle name. So I said, okay, to avoid confusion, I'll add my last name. And then I hyphenated it, because even though in Spanish it's not hyphenated, it was the only way for the systems to deal with two last names. So that's the story.
And so it's Herrero. I just know the Herrero.
Alonso Herrero.
Alonso Herrero. Okay. Almudena Alonso Herrero. Right.
Piñuela García Pérez Manso Sato Herrero. Because we tend to remember, generally we try to remember as many last names as possible. I only know 8.
I knew a student when I was teaching at Lafayette College many years ago, and we only knew him as Muhammad Noor. But we were starting to talk about naming systems in different cultures, and he was from Somalia.
Okay.
And he said in his culture, you add on your name to the string of your father's names, and he knew 87 names.
Wow.
That he had to memorize, and if he has a son, it will be 88.
Wow, okay.
And he can tell when the names stop being Muslim names and start being animist names.
Oh, wow, that
So
is interesting.
it goes even before Islam came to the part of the world where he grew up. So I have a hard enough time remembering, the members of my own family, much less all of their names.
Yeah.
But naming is one of those things that astronomers do. And what are some of the things that you do as an astronomer?
Well, so these days I'm using the James Webb Space Telescope quite a lot. I've been part of one of the instrument teams for now 20 years, and that happened when I went back to Spain back in 2003. I had a lot of experience with other infrared instruments, and we can talk about that later. So I was invited to this European consortium to work on the mid-infrared instrument. I think at the time, JWST launch date was planned for 2008, and it took, there were a lot of delays, and finally launched in 2021, and everything is perfect, working really, really great. So yeah,
knock, knock.
Knock, knock, knock. So after 20 years, it's getting great data, and that's what I'm doing, just dealing with all the data, there's a lot of information, so basically learning every day, because that's the beauty about getting these new instruments.
What's the science question that drives you? What's really motivating your particular work?
So I'm interested in understanding how supermassive black holes that we know that most of the massive galaxies in our local universe have at their centers, I'm interested in learning how they grow in size and how evolve with what we call the host galaxy, so the galaxy where they live in. To do that, what we are trying to do is to get observations that tell us about the gas and the dust in regions very close to this supermassive black hole.
And how does Webb allow you to do that?
Well, I mean, Webb has been great because we have incredibly good sensitivity. So actually, I've been trying to do this for many years using a lot of ground telescopes or using smaller satellites. But now with James Webb, we have both the detail and the sensitivity. So it's like a great combination for.
Well, a part of it is that you're looking in the infrared.
Yes, it's an infrared.
And so what does the infrared give you that, say, Hubble didn't?
Well, infrared is basically telling us about the dust. So the dust emits in the infrared, and so we can. It has like two properties, because dust emits in the infrared, but also the infrared is good to look through dust. And if we think about, for instance, a storm in the desert in Arizona or the Sahara, you know, if you look with your eyes, there is a lot of dust, you don't see anything. If you put on one of those thermal, you use one of those thermal cameras that the military uses, you can see through the dust. So that's
how does that work? How is it possible that you can see through dust with the infrared? What's the fundamental physics going on?
I think it's because the size of the particles are comparable to the wavelength we are using. So that's what is helping us to. But there are parts of the spectral range that are not so good for that. So
Okay.
but yeah, in principle, that's the nice combination. And apart from studying the dust, we can also detect a lot of features that tell us about the gas, the gas in molecular clouds, or the gas that is being ionized by stars, or maybe this active black hole, etc.
Now, people always talk about dust in these clouds in the sky. I'm trying to get my head to picture, is this dust like you find under your bed? Is this dust like a flower? What is the size and how much does it stick together?
Well, so I mean, that's a big question, because in particular for these objects that we are studying, we are not sure. At the beginning, we thought, okay, the dust should be more or less the same everywhere in the universe, in the interstellar medium, so the space between stars. But we think in these environments where you have a lot of energetic processes, so these are supermassive black holes accreting material, and that's creating a lot of energy. We are starting to think that the dust, the larger grains are the ones that are surviving, and maybe the smaller particles get destroyed. But as I said, that's what we think is happening, but that's why we need James Webb. That's one of the.
What you're actually trying to find out.
It's one of the things we're trying to find out. Yes.
How in the world did you get interested in infrared astronomy?
Well, that's. I mean, there's not a lot of story behind that. When I finished my undergraduate degree,
Which is where?
It was in Madrid. It's this place called Universidad Complutense de Madrid. It's one of the largest universities in Madrid. I said, okay, I had done 3 years of physics and 2 years of astronomy. I decided I liked astronomy, and I said, okay, there is a possibility to do a PhD here. So I spoke to some people in my department. At the time, it wasn't for us in Spain, wasn't so easy to find information to apply for grad school in other places. So you would generally stay at your university. And I said, okay, I just, would like to do a thesis. And they said, okay, this is how it went. You prefer stars or galaxies? I said, I prefer galaxies. Okay, they said, okay. And then they said, well, you are going to work in the infrared. And I said, okay. And so that's how I started. They gave me a tape, and it had data from an infrared telescope in the Canary Islands. But this was a very basic instrument. It was a single aperture photometer. Basically,
A one-pixel camera.
yes, you couldn't get any images. You just get the count. How many photons you could observe.
I remember that.
Yes. And even for that time, I think the infrared cameras were very small, right? But they were starting to be, around on different telescopes. So they gave me this tape, and at first, literally after 1 week, I had what we say reduce the data. So basically, I was able to convert these photons counts into numbers, physical numbers. And then I said, now what? And it kind of seemed like I had run out of things to do. So we applied for more observing time. They got more data. And then there were not a lot of expertise in infrared in my department. So I got in touch with one of the professors at Oxford University. And I have to tell you, at the time, we did not have our own computers. We would have to go to the computing center, I think it was called. So you would get an account there, and then you would get an account and email. And then I just got in touch with this professor at Oxford who was an infrared astronomer, Professor Martin Ward. And I said, can I come over for the summer? And he said, oh, sure, come on over for 3 months. And that's what I did. And then I started getting infrared images, and that was it, you know.
So what years were this? What would this have been?
So that first summer in Oxford was 1992. So a
Okay.
long time ago.
Well, what happens the next summer?
So the next summer, so I applied for the Vatican Observatory Summer School.
How did you even hear about it?
You know, so I was, one of the students here was asking me about that. So again, there was almost no internet. I could only read email, so there was no graphical interface. But, you know, you guys used to send posters, really nice posters around that would be, posted somewhere in the department. I saw the announcement. And I said, oh, that looks interesting. Galaxies. I want to learn more about galaxies. I saw the names of the professors, George and Marcia Rickey, who I knew they were infrared people. And I said, okay, this is, very relevant to what I'm trying to do, trying to learn. So I applied. I think a few of the other students in my department also applied. And I was the chosen one. And so then I came here for the school, which was great. And also at the same time, that summer, I heard from this professor in Oxford that he had been trying to get me some funding to go do my PhD in Oxford, and at least the work. So I received the great news that, I could go to Oxford and spend, 2 years there. So yeah, it was fantastic. I mean, really good time.
So you go to the school, you meet a few other professors there.
Yes.
Who are a couple of the people who you've met, who you've stayed in touch with?
The professors and the students?
The professors and the students.
Well, professors George and Marcia Rickey, for sure. And then, of course, because I ended up working at the University of Arizona, I stayed in touch with a lot, like with you. I saw you a few times.
I was there, of course.
Yeah, you were there.
But I was definitely not a galaxy person.
Father Coyne, I mean, a lot of the Jesuits. And then out of the students, I stayed in touch. I think we were about 25, definitely with 15. A lot of people used, I spent many years at the University of Arizona, and that kind of attracted a lot of people, good observatories. So it was like easy to stay in touch with people. I ended up writing papers with some of my colleagues and friends from the school. So, I mean, in that sense was fantastic. With other people who are not working in my field, we're still in touch, just because we became good friends and,
Well, I'm thinking in particular of Roberto.
Yes, Roberto, who is another.
Tell us about Roberto.
So Roberto, yeah, he was.
Full name?
Roberto Maiolino. He's a very famous Italian astronomer. He's a big professor at University of Cambridge in the UK. So he was one of the students at my school. Of course, being Italian, Spanish, of course, it's very easy to connect because we similar, very similar cultures. And then at the time, or before I can remember, he was working with George Rickey. So he had been in Arizona, I think. Oh, no, because he went to Arizona to work with George Rickey as a student. And then he finally got his degree in Florence. And then he came back for a visit. And we actually wrote a paper together with some NICMOS data. So when my first job in Arizona was working with Marcia Rickey. She was the deputy PI of an instrument that was working on the Hubble Space Telescope. So we got a lot of data too.
NICMOS stands for?
Near infrared camera and multi-object spectrograph. I'm not sure, I'm maybe making up the last bits of the acronym. But anyway, it was an instrument that was installed on the Hubble Space Telescope back in 1997. I was lucky enough to go to Cape Canaveral to see the shuttle launch, which was incredible. And I think I was working on Hubble maybe for 6 years, something like that. So anyways, I got to work with Roberto on a paper at the time. And then, of course, then he went to Germany for his postdoctoral position, and we kept bumping into each other, of course, at many conferences. So yeah.
And most recently here at the school.
And here at the school, because and I remember Roberto and I, a few years back, we were thinking about organizing a school, let's, submit a proposal, but I think we got too busy but I'm glad that the other professor, Eiichi Egami,
So Eiichi, who you guys have met earlier at a previous one of these, how did he recruit you guys? How did he come and find you to be, the professors at the school?
Okay, so Eiichi and I worked together also at the University of Arizona on a different infrared instrument, which is called MIPS, and was part of the Spitzer Space Telescope. So we were part of the same team, and we actually ended up being office mates. So we were office mates for, over 2 years, and we got along really well. H is a very calm person. I'm a bit more explosive sometimes, but we just got along very well, and we wrote a few papers together during those times. And then I left, went back to Spain, and again we saw each other because I used to go back to Arizona and work there. And H is a super nice person. He's like so welcoming. Like he always makes sure that when you're there, he's gonna take you out to coffee or to a nice dinner. And we always got along very well, and we haven't worked together in many years, but again, we remained friends. And I don't know, he thought of me when he was organizing the school.
So there are 5 professors altogether, and 3 of you are alums.
Yeah.
H was at the 90 school, and Roberto and you were at the 93 school. Has been, how can I put this? Is the fact that you are an alumna, does it make a difference as to how you teach the students now or what you expect from them?
Yeah, of course. I mean, I'm sure each person has a different experience, but I think a common theme of all these schools is not only the knowledge, which is great, learning about new things, it's just the connections, the personal connections you make with a lot of people. So in a way, when I was preparing all the lectures and everything, I was getting a bit obsessed about what to say, what to do. And then I was thinking, yes, they are going to appreciate all this. They're going to have their notes and everything. But then I just put myself back in time. And of course, back then, I get the impression we were a bit more, I don't know, less informed, I would say. But yeah, I just thought, I know how the school is going to go. I can get a clear idea of what's going to happen. I know there's going to be, because there are students from all over the world, the levels are very different, but that's a great thing because then people can help each other. It's like, I know this, you know that, we can work together. And that actually emulates how we do research. It's like generally there's not a single person who knows everything. I mean, that's for sure. So it just helps you learn, that, this is the way we work in research. It's collaborative and, yeah.
When you were preparing the lectures,
yes,
was there one in particular that you were looking forward to, like, oh, this is going to be so much fun to teach these guys?
Well, it's hard to tell if they are going to be excited about the same things you get excited. I mean, sometimes I got excited because when I was looking at one of the first galaxies we observed, I thought the spectra were not very good. I thought it was very noisy. And then it turns out that that wasn't noise. There was so much detail, that so many things that we couldn't see before. So yeah, I wasn't sure because I think they also come from many different research fields. So, some of them are doing exoplanets or cosmology. So I think it's hard to, and then when you talk to them, it's good because then you hear what they go, that was really impressive. And maybe to me, that wasn't that impressive maybe, but.
Well, of course, the way we're doing the school is the first 2 weeks are galaxies and extragalactic in cosmology. And the next 2 weeks are going to be planets and planetary disks, things like that. So a little bit closer to what I did.
Yes, I know.
But you're talking about how the students received it. How did you feel? What was the one thing that made you jump up? I mean, that story of the galaxy with all the lines is a beautiful one.
It is. So, I mean, for me, I have to say that when I think H was presenting a little bit how we did I didn't, but the commissioning team that, got everything working with the telescope and the instruments. For me, the most amazing thing is when we first saw that image that they released to the public. It's that they pointed at a very bright star, and we could see, those, diffraction spikes that tell us that the telescope is working really well. And when I saw the galaxies in the background, because this is not a very deep image, this was just probably took 2 or 3 seconds. And this is what they call an engineering image. It's something that you're not going to use for science. It's just to demonstrate the telescope is working really well. And then I saw all those galaxies in the background. I thought, this is going to be great. This is going to change so many things. And so many things we couldn't think of ahead of time. That's the beauty, right?
Well, name one of those things in your field that are you just blown away because of the web?
Well, maybe two things. So for nearby galaxies, that we can see water ice. In the central regions of these, active galaxies, or very energetic processes at the centers, in some of them, we can detect water ices.
Water ice.
I just never thought we would detect that. Of course, then you go back to the literature and you see that there are some galaxies in their central regions, they have a lot of dust and it's very embedded and it can be quite cold, even though they are in some surroundings with a lot of energy. Okay, so it is possible to detect these ices. So that was one thing. The other thing is when we were planning our deep observations that we do to try to detect very young galaxies, very faint objects, we had to rely on what the models and simulations would tell us. And I think at the time, the European Consortium decided to use like 60 hours to just stare at this very small piece of sky, hoping that we will detect high redshift galaxies. It's very, very distant objects, very young. And we said, well, the simulations tell us maybe we'll find 1 or 0. And we were thinking, shall we just invest, such a big chunk of time? And we convinced ourselves, yes, okay. And then when we started, not our team, but other team, we started just receiving the first data sets and people were detecting these super young galaxies. We thought, wow, good, we did the right thing. And it was pretty amazing.
Well, this brings up one of the things that I know when the first results, especially that, came back, it was spread out in the press that, oh my gosh, they're finding galaxies that were bigger than anyone expected and the Big Bang must be all wrong. And
yeah.
So what's the truth? What's really going on there?
Well, I mean, the thing is, we generally start by assuming that things work like in the local universe, because that's what we know a little bit better, right? So you assume that stars are forming the same way as we see in nearby galaxies, and that might not be necessarily true. So now we're thinking that in the very young universe, it's more likely that more massive stars are created in larger numbers, and that changes how bright these galaxies are going to be. Basically, they're going to be brighter than with what we were expecting.
So you were showing, I remember one of the lectures, that systematically, the farther back in time you look at galaxies, the more active they are at making these big stars.
Yeah, exactly. So that's what happened in our local universe, in our backyard. Somebody showed, sharing.
Bob is putting up the pictures.
Yes, nice. So yeah, in the local universe, we do have a few galaxies with a lot of stars are being formed, but that's not common. That's not as, in our local universe, there are galaxies like our galaxy are forming new stars, but not at a great rate. But the more you go back in time to the early universe, that's completely different. The supermassive black holes must be growing really fast, and stars are being formed at incredibly high rates.
Because it hasn't had time to do this yet, because it's just been born.
Exactly. So basically things are quite different, compared with,
So we're talking about very early times in the universe.
Okay.
Looking way, way back. And you've been talking about times in your career before there was an internet.
Yes.
Let's go back to what made you decided you wanted to be an astronomer or a scientist in the first place. Where did you grow up? What was your home like?
Well, I grew up in Madrid, in actually central Madrid, big city. We used to go to my mother's hometown, which is called Segovia. It's a beautiful historic town just north of Madrid. And we used to spend the summers, not in the small town, but in sort of the outskirts, in something like an hacienda kind of place. So a small house and a lot of land. So we could see, it was very common to be able to look at the sky and see something, right? And one of my uncles, who was a professor, fluid mechanics, but he liked astronomy. So he would always bring, in the summers, he would bring a small telescope, and we would even go to either more, the darker places, and we would just look through this telescope. And then like most people in our generation, we watched Cosmos, the Carl Sagan TV show. I think that inspired a lot of people. Okay, so I was always interested in astronomy.
So what did your parents do?
But I wanted to be a painter. Sorry, so yeah, because my father was a painter, a professional painter. My mom was a painter, but not professional one. So I grew up also in this kind of environment, and I was I was pretty good at drawing and things. So I actually was preparing in high school. I was preparing myself to take the art school exam. But I also decided to take science in high school instead of humanities. And then at the very last minute, I thought, it's going to be really hard to make a living out of being an artist. I mean, you have to be really good. You need the contacts. It just seemed a lot harder than becoming a physicist. So last minute, I just said, I really upset my father, but I made my mother very happy. So I said, I will go into physics because I was interested in astronomy.
I remember when I was teaching that somebody's should be muting. We're hearing a conversation we shouldn't be hearing.
This week, let's go to it. Till Sunday?
Okay.
Just mute everybody.
Trying to figure out who's.
Yeah.
I think almost everybody here is muted. So I'll blame Joel. I think Joel's the only one I see who's not muted. No, perfect. Okay, great. So I was telling the story when I was teaching astronomy back at Lafayette College, and we had a lot of non-majors. One of the things I discovered was all the science nerds would, do fine on anything that had equations. But when you'd spread out a dozen galaxies and say, which ones are spirals and which ones are barred spirals and which are tight, they had no idea.
Really?
They didn't know how to look.
Oh.
But it was the art majors
Oh, yeah.
who immediately knew how to use their eyes.
Yeah.
And of course, that's what Galileo is famous for. He had studied painting. When he looked at the moon through the telescope, he knew it was a sphere and he knew how to portray it as a sphere.
Yeah.
In a way that, I mean, he was not the first person to look at the moon through a telescope, but he was the first person to actually draw a picture to make you think, yeah, that's what it looks like.
Yeah, and it's actually, I mean, I'm super interested in this subject, and I actually wrote a book in Spanish about something related. Yeah, imagine how hard it is to look through a telescope, has to be dark, otherwise, you don't see the detail. And at the same time, you try to draw something. And one of the exercises you can take when you're learning art, when you are like drawing or painting a model, they ask you to draw without looking at the piece of paper or it's incredibly difficult. You totally lose the sense of proportion. And then you look at what you've done and it's like, wow, okay, this is really bad. And it's similar to trying to draw something while you're looking through a telescope. I mean, it's added the fact that there's no light, that your eyes probably are tired. Mm-hmm. So yeah,
one of the people who writes for us on our Sacred Space site is an Irish woman, Deirdre Gallagher, and she does art.
Oh, wow.
She gave herself the challenge in 2009 to try to reproduce Galileo's drawings of the moon with the telescope similar to what Galileo was using.
Yeah, that's
which was, just astonishing that Galileo could see anything.
Yeah.
But she also engages school kids.
Ah, nice.
Because that drawing is what draws them into paying attention to what you're looking at.
Exactly, and you have to focus, and yeah.
So I imagine that must actually have an effect on your science.
Yeah, I think I'm a very visual person. I'm not very good with words, and I have not a very good memory sometimes. But I think, James Webb. The amazing images that we get, and it's something that draws me totally. Although I wanted to work when I started my PhD, I wanted to do models. I really like the math part of the things, but as it turns out, I became an observational astronomer, and yeah, it's fine.
So there's still a gap there. In the Spanish schools, do you have to specialize in science or the arts, the humanities at an early age?
Well, I think my time it was about 16.
Okay.
I think it's even earlier these days. But at my time, it was very flexible. You could do humanities in high school and then go and study medicine or engineering if you wanted to, or the other way around. Mm-hmm. These days, it's less flexible. If you decide to go into pure science, I wouldn't say impossible, but it's quite hard to, when you go to universities, to change completely.
Which is a shame. I started out studying history.
Oh, wow.
At a liberal arts college and then transferred into MIT.
Yeah, and I think there's something like I appreciate in like the American system or in Canada. My son is studying in Canada, and he started he chose Earth and Ocean Sciences, and because he liked that. And then he told me after first year, he said, "Oh, way too much physics. I'm gonna go into financial economics." It's like, what? Okay. So, oh yeah, those are the Galileo.
So if you're looking in the chat, Bob has put up some of the Galileo images.
Yeah. So I like the idea that you are able to change your mind, because once you start taking these classes, maybe that's not what you thought it would be. So Spanish system still is very rigid.
So you were in high school, you're doing the arts. At what point you switched over to the sciences?
No, so I was doing the arts I was doing sort of independently.
Oh, okay.
Because my father had an art school at the time, so I could prepare with him. So that was I was lucky that way. So no, I was just doing science, and actually I didn't take a technical drawing, which is what the engineers do, because I wasn't very good at that. So even that technical drawing, I just dropped immediately as soon as I could.
Do you have siblings, brothers and sisters?
I have 3 brothers, younger brothers. So yeah, it's.
Are they all in science, or are they artists, or what?
No, so there's one after me. He's a judge. Then the third one is a chemist, and the last one, he studied journalism, but now he's a graphic designer.
Okay.
So he's also very artistic, and his art comes, he went through humanities, but eventually he came kind of back, and he does a lot of computer, graphic art and things like that.
And you mentioned your son, so what about your family?
Well, about the...
I mean, where are your kids? What are they doing?
Okay, so I only have one son. He is 19, so he's studying at the University of Victoria in British Columbia in Canada. He's just finished his 2nd year. He also wants to be a pilot, so he's going to flight school there. He started doing his solo flights, which of course make me very nervous.
Right, there's at least one pilot in this.
Good.
One Pablo.
Oh yeah, okay. So yeah, my son is loving the flying. Yeah.
Yeah, that's great. That's awesome.
Yeah. So you fly like big planes now, or just?
Yeah, just a private license.
Yeah, that's what he's trying to get. So he's done probably like about 25 hours of flying, and he's gonna study for the theoretical part over the summer. Take the theoretical part, and then I don't know, he has to do 75 hours. But he wants to become a professional pilot. So, and that's like being a postdoc, to be honest, because because they have to move around and sort of try to get as many hours as possible, and yeah.
I have at least 2 other astronomer friends whose children are pilots.
Yeah,
so I think there's a connection there.
Yeah, maybe it's because I don't like flying. He's just trying to
overcome that. Well, at this point, let's take a break and see if anyone in the audience here has questions they want to bring up. I've been trying to read quickly in the Zoom chat to see if there's anybody who's been asking questions, but it's tough to do that.
Yeah, I've been posting a lot of stuff there.
Yeah. So anyone who's got a question, raise your hand and volunteer.
We don't have a lot.
I have a question.
Okay, there's 2 people talking and I can't hear who's who. Oh, I think that other person is not a question. It's just a background.
So nothing is.
That's interesting. Everyone's muted there. Okay, JP, go ahead.
Yeah, here I'm a high school teacher in Phoenix, Arizona, at Jesuit school, and a group of students is building a CubeSat, a 2-unit CubeSat to be launched by NASA. And the idea of that is to study and analyze particles of dust in the southwest of the US in Arizona. And it's an infrared. It was originally to be an infrared, and now they are changing to an ultraviolet.
Okay.
So what will be your recommendation for that? Infrared will be better, you think, for that?
I mean, I would say infrared is better, but I think from the UV they can get other properties of the dust. I think the what you call it, the cross sections and things, and the scattering.
No.
So I think ideally you would want both. I think I don't know why they changed their minds. Maybe they.
Well, the infrared is really hard to keep cold.
Yeah, it will be a lot more expensive to build it. You need to cool it a little bit, whereas the ultraviolet instrument is a lot easier.
That is why we're trying to switch to ultraviolet, because infrared is really complex.
Yeah, you need to cool it a little bit. Yeah.
I just thought of that when you were talking about analyzing the dust with the JST through infrared. I was like, well, that's kind of like what we're doing, not with JST, well, not with James Webb, right? But with a little tiny satellite with a little tiny camera, but similar.
Right. But it's also a different kind of dust. I think the dust they're looking at in the atmosphere may be a different size or different composition.
Yeah.
Yeah.
What is the composition of the dust that you guys are looking at? What is it made out of?
So it's mostly silicates and graphites. So silicates are kind of similar to sand grains, and graphite is, just like carbon, made of
How
carbon.
do they know that? How do you know that?
How do I know that? Because I read about it.
Okay.
No.
How do they know about it?
No, you look at the, you take spectra and I think you compare with samples in the lab. And sometimes when you look at the dust in other objects, like I remember reading some papers a few years ago, where they were actually trying to get the composition of the dust in these quasars, these very bright accreting supermassive black holes that tend to be quite distant. And they were identifying like, I forget now, but like olivine, things like, like minerals that we can observe, like semi-precious stones. And even some people said, they can detect diamonds, because diamonds is basically crystallized carbon. And to me, that is so amazing that you can detect this.
And from what I know of it, it's mostly in the infrared where you can do that.
Yes.
These minerals show up in the infrared.
Infrared, and then I'm sure that people will be doing this with James Webb, because we can get more detail. We can get the spectra. It's not only more sensitive, we can get more detail, so it might be easier to identify different elements and different.
One of the things that puzzled me when I remember listening to one of your talks, and you were showing one of the cameras, rather than just giving you a spectrum, would be taking images through different filters.
Yes.
And they would choose a narrow filter right at a place where there is an important absorption feature, and you'd be seeing it if it's there or not. But what happens if the thing you're looking at is redshifted? Then that feature won't be in that narrow filter anymore.
Yeah. So generally, at least in my field of research, we know the distance of these objects, these galaxies in particular. But yeah, if your galaxy is farther away, the light is gonna, what we say, is gonna redshift, so it's gonna move towards longer wavelengths. So you need to have an idea of what distance this galaxy is. Otherwise, your observation might not be targeting the particular part of the spectrum you need. So yeah.
So that's something you do worry about.
We do worry. One thing we worry about is in these nearby galaxies, the filters, even if we say they are narrow, the piece of the electromagnetic spectrum that they get is pretty large.
Oh, it's still pretty large.
So you can get, different things into your filter, and the filter integrates everything. So trying to separate what's what sometimes can be a bit difficult.
One last question. This school, like the school you went to in '93, is being held in Rome. Had you ever visited Rome before you came to the school in '93?
No.
And what was being in Rome like back then? What was the thing that excited you?
Okay, so I think maybe Italy was my second or third foreign country I visited. I think at the time it wasn't, travel wasn't so common. And I mean, I love Castel Gandolfo because it's a beautiful town. It has the lake. But then going into Rome, and for me, Rome is fantastic because having all this Roman stuff from the ancient times, to all the churches, I was just blown away. And it's one of those cases where you've seen the pictures in books, and it's like, oh yeah, okay, I'm not gonna be, impressed. And then you go see the Colosseum, or you see, St. Peter's, and you're like, wow, okay. So that was just great. That's also the cultural part to have access to, we also went to Florence, and of course I loved Florence. And yeah, it was just, we visited all the other smaller towns. So for me, it was very important because at the time it wasn't so easy to go unless you were super rich, right? It wasn't so common. So I took Italian before coming to the school because I also wanted to be able to communicate a little bit. So that for me, it was just really a great experience.
You've had students working with you now in Spain.
Yes.
Have you sent any of them to the school over the years?
I think a few have applied for, but never got in.
Oh,
No,
what-
that's
what
okay.
did we do wrong?
No. I mean, I'm sure you do get a lot of applications.
We
and
had
you-
175 applying for
and
the
I
25
can
slots.
imagine how hard it is to actually try to, who are the best ones, and yeah. So, but yeah, I always recommend the school to students, and whether they listen to me or not, that's different. But yeah, I mean, this is a great. I always tell people, anybody who knows me a little bit is like, I talk about this summer school because it was like a unique experience in my life.
If you could summarize the school in 25 words or less, as they say, if you could just as the cap to this whole conversation, what the Vatican Observatory Summer Schools have meant, how would you put it?
I would say it meant a huge portion of my scientific career, and I just made a lot of friends, and I learned to do research with other people. I think that was again, we had the hands-on exercises using programs that I had never used before. So I mean, it's not a beautiful, I'm not putting it in nice words, but I would say as a short summary, it really changed my career. It had a huge influence in my career, and for that I'm super grateful.
Well, thank you so much. We're grateful that you've been part of this conversation. And everybody here, I'm sure, has had a great time listening to and hearing your stories. Thanks a whole lot for being part of this year's Vatican Observatory Summer School.
Yeah, thank you for having me, of course. Goodbye.
And that's it. We'll see you next full moon.
Thank you all. JP, good to see you. Hope you're well.
I will see you, Chris, in 1 hour.
Thank you.
Good to see you all. Thanks for everything.
Thank you. Bob, I'm sorry if I was the cause of the background. I was quite annoyed myself, and there's no conversation here locally, but if I was, my apologies.
No problem. All righty. Bye all.
Bye.